Welcome to 11.1, circumference and arc length. So today, our circumference, we want to understand how far it is around a circle. We just got done doing the circle equation. So now we want to go with distance, the distance around a circle. And that is defined as pi times the diameter. Pi is a number, which is 3.14, and we know what the diameter is. So if we take pi, 3.14 times the diameter, 3 times the diameter, that will take us all the way around the circle one time. So where did they get this? They got this from taking the distance of the diameter, laying it around the circle, and it takes just under 3 times to go around the circle. And that little extra bit there is the 0.14. So pi is your 3.14. And we know distance is also twice the radius, so that's where the 2 and the r come from when you use 2 pi r. So you can use pi times diameter or 2 pi r, because 2r is the diameter. Another thing that we want to talk about is radians, converting between degrees and radians. Radians are the measurement around the circle in terms of pi. Okay, so if our radius is 1 unit and our diameter then is 2, okay, the circumference around that circle is going to be 2 pi. Okay, so 360 degrees is the degree all the way around, and that's going to equal 2 pi. Well, if we divide by 2, then pi is equal to 180 degrees. Now, pi represents the distance around the circle, the generic unit measure around a circle. Obviously, radius is not always 1, but the generic unit measure is pi equals 180. And we can start to use that as a proportion. Pi over 180, that's radians over degrees. Okay, so when we get to those problems, I'll show you the easy way of calculating what those are. All right, let's get started on that one. Find the indicated measure, the circumference of a circle with a radius of 6 inches. So r is 6. If r is 6, then we can use 2 pi r for our formula. So the circumference is going to equal 2 times pi times 6, or 12 pi inches. Okay, sorry about the sound. So that's 12 pi inches, and you can use a calculator to take 12 times pi and get the decimal form. Number 2, circumference of a circle with a diameter of 5 inches. So now we have the diameter given. So the circumference equals pi times diameter. Well, if the diameter is 5, then the circumference is 5 pi inches. Okay? Diameter of a circle with circumference 63. Now they gave you the circumference this time. So the circumference is 63, and we want to know the diameter. So we divide by pi. So your diameter would be 63 over pi. And if you divide that by 3, it'd be 20 plus, probably, feet. So if we use our calculator, that's going to be 20.05 inches. And then 5 times pi from the previous problem is 15.7. And 12 times pi is going to be 37.7. Okay, number 4 is radius of a circle with a circumference of 28 pi. So what's the radius? So we're going to use c equals 2 pi r. So we want the radius. So the circumference is 28. So 28 goes into the c position, 2 pi r. So to get r by itself, we're going to divide by 2 pi. So when we do that, radius equals 28 over 2 is 14, and the pi is still in the denominator. So now we take 14 divided by pi. So we have 4.5. So our exact answer is 14 pi. The approximation is 4.5. All right, so there's a difference between exact and rounded. All right, and that's the same thing for all the other ones that we've answered. All right, arc length. You can set up a proportion with part to whole. So again, part to the whole equals part to the whole. So what does that mean? It means we can do this 45 degrees. So 45 degrees is to the whole 360 degrees of the circle, as the part of the length of that arc is to the whole length. The whole length is your circumference, 2 pi r. In this case, we have our diameter of 8. So what we can do, instead of saying 2 pi r, we can say the diameter 8 times pi. That's the whole circumference of the circle. Circumference equals pi times diameter. So that's the whole part, all right, the whole piece. And so what's the arc length? So we don't know what the arc length of AB is. So we want the arc length of that. That goes in that position. That's our x. We don't know it. So there's 3 pieces that we do know and 1 that we don't know. So now we could label that x if we wanted to, and we could cross multiply. So we can take 8 times pi times 45. Okay, so if we want the exact answer, just do 8 times 45, and that would be 360 pi equals 360 times x, the other cross of the multiplication. Divide by 360, and the 360s will reduce out, and you have x equals pi. That's the exact answer, and then we want this as the length of the arc, okay, which is 3.14. That's radian measurement. If we wanted the degrees, then we need to turn the radians into degrees, but we already have the degrees. That's 45 degrees. Okay, so again, let's try DE, number 6. So we have the arc length, 8.73, is to the whole circumference. So we have the radius here, so circumference equals 2 pi r. So this would be 2 times pi times 10, or 20 pi. And then the degree, we don't know what the degree of arc length DE is, but the whole circle is 360. So you're setting up these proportions. So now we multiply 8.73 times 360, and we get 3,142.8 equals 20 pi times x. Now divide by 20 pi. So we leave the pi there for an exact answer, and then we'll use 3.14 at the end. So now we take 3,142.8 divided by parentheses 20 times pi, end parentheses. So that's 62.8. We do that division and we get 50.02. All right, so the exact answer, we have to take 3,142.8 divided by 20 and leave pi where it's at. And that gives us 157.14 over pi. That's the exact answer, which is funny because we already have a decimal. So that's the one we want. This is called our exact answer. All right, let's do the same thing. Circumference. We want the circumference here. And we don't know the radius. We don't know the diameter. So we're just going to use the diameter one. So pi times d. And that's the whole thing. Pi times d. And the arc length goes above that. 7.5 is to the whole piece, as 76 is to the whole 360. Okay, part to whole, part to whole. Now we just find d. So 7.5 times 360 equals 2,700. And then we have 76 pi d. So we're going to divide by 76 pi. So our exact answer, we take 2,700 divided by 76, and that gives us 35.5 all over pi. That's the exact answer. That equals d. And now we divide it by pi. And we get 11.3 is your diameter. That would be the answer we want. Okay, now we want to find the radius. So we'll use 2 pi r for our circumference formula. So the total circumference is 2 pi r. We don't know the radius, but we do know what the arc length is. We don't care about LM because they're telling us this is our degree and this is our arc length. So the partial circumference is 38.95. That's the part to the whole, as 260 degrees is to the whole 360. Cross multiply 38.95 times 360. That gives us 14,022. And 2 times 260 is 520 times pi times r. So we're going to divide by 520 pi. So take 14,022 divided by 520, and we get 269.65 over pi. So we divide it by pi, and we get 85.8 for the radius. Sorry about that. I mean 8.58, so 8.6. I had the decimal in the wrong spot there. So 8.6. All right, so be careful of your decimals and make sure it makes sense. The reason I knew that 85.8 wasn't right is because my arc length here is only 38.95. There's no way the radius is bigger than that 38.95. So it's a good thing to kind of have an idea of your lengths so that you know you're not making a huge mistake. All right, let's keep going. Describe and correct the error in finding the circumference. Okay, so let's just do the problem. Don't look over here. So the circumference given the diameter is pi times diameter. So C equals pi times 9. All right, so that's 9 pi inches, or 9 times pi. When you calculate it, it gives you 28.3 inches. All right, now let's take a look at what they have here. They took 2 pi times r, which is the circumference. All right, that's fine. But they used 9 for the radius, and that's what they did wrong. Okay, moving on. Describe and correct the error in finding the length. All right, so again, don't look at this. Let's do the length of GH. Arc length, we don't know, is to the whole circumference. We have the radius here, so we'll use 2 pi times 5. That's your circumference of the whole circle, equals the degree of that arc length, 75, as to the whole degree of the circle. So cross multiply 360x equals 75 times 2 times 5 is 10 times pi. We'll just do that. And that gives us 2,356.2. So we'll divide by 360, and we get 65.4. And that doesn't look right. So let me see if I hit everything correct for my decimals. Right, that should be 6.54. So using the calculator on my phone, sometimes it doesn't pick up on what I'm tapping. Another reason why you need to make sure this makes sense. So x represents the arc length GH, okay? And that makes a little sense. If the radius is 5, this arc length looks like it might be a little bit bigger than that. So that's what is wrong. Now let's see what they did wrong. So we erase all this, take a look, and what did they do? They said the arc length times 2 pi r. Okay, so that means they took this this piece right here times the 2 pi r. And that's not what they should have done. Okay, so they have everything out of position here. So that's what they did wrong. Modeling real life. Okay, don't let these things make you look at them and be like, oh, I don't want to do them. They're very simple. What are we doing? We're doing circumference equals pi times diameter. Okay, that's what the whole lesson's about. So let's read this and see how this pertains to the circumference. Measuring a wheel, which is a circle, is used to calculate the length of a path. Because if you took the circumference of the tire and you cut it and then laid it flat, it would be a straight line, which gives us distance. So circumference gives us a distance along a path. Okay, so from here to here, that would be the whole circumference. All right, so the diameter of the wheel is 8 inches. So we'll do this. This is 8 inches. The wheel makes 87 complete turns. That's what a revolution is. So 87 times the circumference is going to equal the length of the path. How many feet long is the path? That's what it's asking for. So the circumference of the wheel turns 87 times, and that'll be 87 circumferences. That'll be the whole length of the path. So all we need to do is figure out the circumference and multiply times 87. So we have the diameter, so pi times 8 on your calculator is going to be 25.132. So 87 times 25.133, basically. Whatever's on your calculator, take it times 87, and you get 2,186.5 feet long. So 5,280 feet is a mile, so it's not quite half a mile. All right, you ride your bike 40 meters. All right, so you're going 40 meters, this whole length, right? And it's the backwards of what we just did, I bet. How many complete revolutions does the front wheel make? All right, so number one, stop. What it asks is always your x. So on the last problem, we did 87 times the circumference of the wheels. That made the length of the path. So our length of the path is 40, okay? We don't know how many revolutions the bike is taking. Now, the wheel on the last one, they made 87 revolutions. So this bike, we don't know. That's our x. We can figure out the circumference by doing a few things. So it tells us that the radius is 32.5 centimeters. So circumference in terms of radius is 2 pi r. So 2 times pi times 32.5. Got the x in there, and that equals 40. So now we divide by that whole thing. So 40 divided by, use parentheses, 2 pi 32.5. All right, so let's put that in our calculator. 40 divided by, parentheses, 2 times pi times 32.5, and then close parentheses, and then hit equals. Okay? And when you do that, you get 0.1958. So 0.1958. But that's wrong, because 32.5 is in some centimeters, and our whole length is in meters. So we either need to convert 40 to centimeters or 32.5 to meters. Let's go ahead and convert it to meters, okay? So there's 100 centimeters in 1 meter, okay? So all we have to do is move our decimal 2 places to the left, and that's our meters, okay? And then we move our decimal here, and now everything's in terms of meters. So let's try that again. 40 divided by, parentheses, 2 times pi times 0.325, end parentheses, and then hit equals. And we get 19.6 revolutions. Again, making sense of weird numbers that you get on your calculator. Okay, finding the perimeter of the shaded area here, all right? Well, let's find the perimeter of, we don't need the perimeter of the rectangle. We want the perimeter or the circumference of the circle, because we already have the bottom, 13, which is the same as the top. All we need is the circumference of half of that circle and the circumference of half of that circle. And we add it to 26. 13 plus 13 is 26. But this half circle is the same size as that half circle, which makes a whole circle. So we just need to take 26 plus the circumference, and that'll give us the total perimeter of the shaded area. which would look like this. So you get 13 up here, 13 there, and then the circumference of the circle. You add all that together. So we have the diameter here is 6, so we're going to do pi times diameter, or pi times 6. So 6 times the pi is going to be 18.84. So 26 plus 18.85. If you have the long version on your calculator, just leave it on the screen. So we get 44.85 units. That's the perimeter. Okay, same thing here. We have 6 plus 6. That's part of the perimeter. All right. Now we need this quarter of a circle. I say quarter because this is 90 degrees here. And 90 is 1/4 of the circle, or 1/4 of your circumference as well. And you have 2 of those. All right, so plus 1/4 of the circumference. Because they're the same size circles, we can do this. So that's 1/2 of a whole circle. So we have 12, and we're going to add 1/2 of the circumference of the circle. So the radius is given, so we're going to do 2 pi r. So 2 pi times 3 is the radius, or 6 pi. And we just got done doing 6 pi on the last problem. That was 18.85. So, and we want 1/2 of this. That's the whole circumference, so we got to take half. So divide by 2. We get 9.42. And we're going to add that to 12. And that gives 21.42 units. That's your perimeter of the shaded region, which looks like this. That's a bad picture, but that's the perimeter. 6, 6, and then our circumference, half circumference. Okay, same thing here. I want you to notice this is 90, this is 90, this is 90, and this is 90. You have 4 of those. So 4 90s makes 360. So these arc lengths, 4 of those added together would be the total circumference. And we just add, and they're all the same length, so we don't need to worry about different ones. So we add all the other pieces, the 2 plus the 6 plus another 2 plus another 6. But is it 6? It's not. Notice 6 is the whole length. And this little piece is 2. This is 6, and this little piece is 2. And these are all even, so that out of the 6, you have 4 units left, so that has to be 2, and that has to be 2. So all of these things here are helpful. So we need to take the circumference plus 2, plus 2, plus 2, plus 2. Just the side pieces. We're just doing perimeter. We're not doing area. That's another day. So we have 8. 2 plus 2 plus 2 plus 2 is 8. And now we just need to find the circumference. So our radius of these circles is 2. So 2 pi r will be our total circumference. 2 pi times 2, or 4 pi, we're adding it to 8, plus 8. So 4 times pi plus 8. That gives us the total perimeter to be 20.6 units. That's the shaded region. All right, now these all look weird, but just take a moment. We want the perimeter, so we take the flat stuff first. 5 plus 5 plus 5. Now, what you need to know that 120 degrees is 1/3 of 360. So we want the arc length, which is 1/3 of the circumference of that circle. And they all happen to be the same. There are 3 of them. So if we multiply that by 3, the 1/3 and the 3 go away, leaving the total circumference of one circle. Okay, so that's all we got to do is find the circumference of one of those circles because they're all the same. The issue is, what is the length of your radii? And if you move this radius down and this radius over, that radius hits there, this radius hits there, and look at what we have here. The diameter, 2 radii together make a diameter. So the diameter is 5. So we're going to say pi times diameter is your circumference. in this case, 5 pi. So we have 5 plus 5 plus 5 is 15 plus 5 pi. That's going to be the total perimeter around this. So 5 times pi on your calculator plus 15. That gives us 30.7 units for the perimeter of that weird shape. So it's like this. All right, now how do we convert angle measurement to radians? It's really simple. If you want radians, then the radian value goes on top of your proportion statement. So we have 70 degrees times pi, 3.14, is to the total part 180 degrees. All right, just like if you wanted to convert what 5 feet was to inches, you would say, hey, there's 12 inches in 1 foot. You multiply by a ratio of something. So here we have radians, and this is degrees down here. Now notice up here in what I'm saying, notice that feet is in the top and in the bottom. Units reduce just like variables. And the only thing left here would be 60 inches. So we need to understand that degrees in the denominator with the 180 will cancel with the degree in the denominator, the 180. And what you're left with is radians. So 70 pi over 180 will be what 70 degrees is in terms of radian measurement, which is pi units. So it takes 70 times pi. Well, actually, let's reduce it first. We can reduce by 10. We get 7 pi over 18. So let's take 7 times pi equals, and then divide by 180, and you're going to get 1.222. So I'll erase this part here in a second, but let me show you something. Remember, all the way around is 2 pi units when the radius is 1. So halfway around is 180, which is the same as pi in radians. We have 180 degrees is the same thing as pi in radian measurement. All right, which is 3.14. Half of 180 is 90. So at 90 degrees, half of 3.14, or half of pi, is going to be 1.57. So the 1.22, starting at 0 here, is somewhere up in here, which is what 70 degrees looks like. All right? So that's just teaching you a kind of what we're dealing with. 180 degrees is going to be pi. So the next one's 300 degrees. So 90 and 90 and 90 gets me to 270. So from 0 all the way around to 300 degrees, so we're going all the way around to there, it's going to be 1.57 is 90, plus 180, 90 and 180 gets me to 270. So 1.57 plus 3.14 is 4.71. So 300 degrees, when I do the conversion, better be more than 4.71. What's 2 pi? 2 times 3.14 is 6.28. So 300 degrees should be between 6.28 and 5.71. So I'm going to erase that, other than those bottom values there. And show you, I'll just write them up here. So 6.28 and 4.71, 3.14. So those are your values in terms of radians and pi. All right, so we take 300 times pi over 180. Again, if we reduce it by 10, we get 30 pi over 18. Reduce that by 3, we get 10 pi over 6. We can reduce it by 2, we get 5 pi over 3. Okay, so wait, you didn't have to do that. I'm just showing you should reduce it. 5 times pi divided by 3 is 5.23, which is about where we said it should be. That's the distance around the unit circle to that point in terms of pi values. All right, 5.23. If you took 300 times pi and divided by 180, you get the same thing. 300 times pi divided by 180. 5.24, 5.234, 5, whatever. Okay, now we're going to go backwards. We have radians and we want degrees. So 11 pi over 12, remember how we wanted the degrees to cancel? We want the 180 on top and the pi on the bottom. So we flipped this upside down so that the pi radian values cancel out. It's what you want goes on top. We want degrees, so degree goes on top. So now you just take 11 times 180 and you divide it by 12. And that's going to give you 165 degrees. Okay, so just to show you what 11 pi over 12 is, take 11 times pi divided by 12. And you get 0.2917. That's not right. I must have mishit a button. 11 times pi divided by 12. 2.88. So from 0 to 2.88. Okay, which 165 degrees, if 3.14 is 180, then 165 is right there. That makes sense. All right, converting this radians, we take pi over 8. We want to remove the radians. We want degrees, so degrees goes on top. The pi reduces, and now you have 180 divided by 8. You get 22.5 degrees. And what is pi divided by 8? It's 0.39, which is between 0 and 1.57. That's right. All right. Now, don't let this fool you. Let me explain how to do this. It's not difficult. Again, it's how many revolutions. We don't know the revolutions. Times the circumference. Okay. How many revolutions does the smaller gear complete during a single revolution of the larger gear? Okay. So let's find what one revolution of the larger gear is. What length is that if we rolled it one full turn? So the circumference of that, we have the radius, so 2 pi times 7. So 14 pi is one revolution. All right, so take 14 times pi on your calculator, and you get 43.98. All right, now listen, that's this distance. All right, let's find the circumference, one circumference of the small one. Again, we have the radius, so 6 pi. So 6 times pi is 18.85. So it wants to know how many 18.85s, like 18.85, 18.85, and another one, 18.85, can you get to the end of the 43.98? Well, how do I figure that out? Well, you just take the total distance that you have and divide it by the 18.85. So let's do that. Let's take 43.98 divided by 18.85. And it's 2.33 revolutions. Okay? So if I said this was 2 inches and this whole thing was 12 inches, and I said, well, how many 2 inches go into the 12 inches? Wouldn't you take 12 divided by the 2 and say that it was 6? So sometimes it's easier to use simple numbers rather than these decimals and stuff for you to understand that you should divide the bigger one by the smaller one. All right. The Landon Eye is a Ferris wheel in London, England, with cars that travel, these little things are cars, okay, 0.26 meters per second. All right. How many minutes does it take the London Eye to complete one full revolution? All right, so let's figure out what one revolution is, or one circumference. We have the radius, so it's 2 pi times 67.5 meters. Okay, so do that on your calculator. 2 times pi times 67.5. I get 424.11. 0.12 really. That's the total circumference. All right, now, if let's do what I just said on the last problem. Let's use some simple numbers. If I had to drive 60 miles and I'm moving at a rate of 30 miles per hour, how long would it take me to get to 60 miles? You would say it'd take me 2 hours because I'm only going 30 miles in 1 hour, but I got 60 miles to go. So it would take me 2 hours. Well, how would I do that? I would have to divide the distance by the rate. Well, this is your circumference is your distance. So you're going to divide it by the rate, or 0.26 meters per second. Now, what's it in minutes? Okay, so let's do this part first. 424.12 divided by 0.26. That's going to get us, okay, so the meters cancel out in division. We're going to get 1,631.23 seconds. So there's 60 seconds in 1 minute. So I want minutes. So just like radians and degrees, what do I want? I want minutes. So 1 minute goes on top because I want minutes, and 60 seconds goes on bottom. That's how you know how to set up a fraction ratio to change your units. What you want always goes on top. So now what do we have here? 1,631.23 times 1 is just that, and then divide it by 60. And now you know it takes 27.19 minutes to go all the way around on that Ferris wheel. And that is the end of your assignment.